professional that has been working with cloud computing. His name is Ramin, Elahi, and he'll be showing us what cloud computing is all about.
Okay, thank you much. Good day all. My name is Ramin Elahi. I'm an adjunct faculty with UC Santa Cruz Extension in Silicon Valley. And I want to welcome you all to this technical session on cloud and data center storage technologies. And I want to also thank the Electrical Engineering Department and Dr. Raisi in particular for inviting me to present some of the major trends, some of the talked about technologies in this area. And I know that almost all of you are working in your field of studies, electrical engineering, computer science, and information science, working with data. And I'm sure after you finish studies, you are going to be landing a job that deals with data. So it is part of our life at a personal level, and later on going to be part of our professional career. So here, when we decided on this talk, the expectations and goal was to provide general awareness, general knowledge about these technologies. And not knowing exact your technical backgrounds, I try to stay very at the 30 feet overview, and definitely in this couple hours don't have time to go into depth and length of any of the topics. So we are going to scratch the surface pretty much anything under the sun dealing with the cloud data storage. And later on at the end of the talk we can go ahead and discuss that where are the sources that you can get more detailed information on any of these topics. So again, that is the goal. And I want to make all of the classes that I do, sessions that I do, I want to make it interactive. Now, considering the limited time that we have, unless there's a burning question, go ahead and please let's go ahead and wait until the we have a lunch time that we can discuss some of those. Or at the end, I made sure that the organizers provide the ample time for Q&A, and we can go ahead and discuss anything. And after the talk, I'm going to be here until the last person leaves and talking about this, because it's my passion and education, and particularly these topics. So we can talk and get somewhere. Okay. These are I want to start off with the major trends. And by the way, these slides, I'm going to make it available not in the PowerPoint but in the PDF, and I just have to get some email and for distribution of it. So again, you are going to see these slides again. These are the some of the major trends today in the world of data storage, data center, and cloud. All right. Now, and this is this area today is very, very dynamic, new technologies, and I'm sure as soon as I finish with this slide, another technology, a newer technology probably came along and enhanced and became a trend. But fundamentally, these are the stuff that you can count on for the near future as some of the major trends. We start with the flash, and I'm only concentrate on a few of those boxes because definitely don't have time to go over all of them. Flash is another way of doing storage. Traditionally, all of our storage are done using spinning iron drives, hard disks to store your data. Now flash, which is a semiconductor storage, and every one of us own one right this minute if you are carrying an iPhone, iPad, a laptop. So the idea is using the memory-like, cache-like, RAM-like storage media for your storage, which is much faster and with a much higher performance. So there are many, many companies now that they are trying to design their storage system made up only with semiconductor storage, which is much faster and higher performance. Next is software-defined network. Through virtualization, we can simulate. Through software, we can simulate, emulate anything. We can simulate a bunch of servers running different instances of operating system. Now we can go ahead and make images of these 3 servers, software images, and run it on one CPU, on one software, on one hardware. Why cannot we emulate and simulate the entire data center? We are emulating our routers, network switches with a bunch of codes and software. It's much cheaper and much more efficient. So that's another major trend that people are working on: software-defined network, software-defined data centers. Mobility. When the generation of generating data, or when the data is no longer anchored to a specific laptop, desktop, or to a particular device. Data today can be generated at the personal level, at the corporate level, from a variety of different sources, from iPhone, from iPad, anything that has some sort of a transmitting interface can generate and receive data. And bulk of the data that we are facing with is coming from the mobile devices. And every one of us at least have a few of those. Next, we talk about cloud, which is the centerpiece of this talk here. Cloud technology is been with us for the last 10, 15 years. And in fact, every one of us in this room are the consumer, are the user of the cloud. Not for the past few years, since the first time we signed up to having our own personal private email mailboxes on Yahoo, Gmail, Hotmail. So we are user and the consumers of cloud, and there are many services, solutions offered through the cloud. And in the nutshell, to put it very, very simply, using the cloud is renting versus owning. And we'll talk more about this later on when we get to some of these services. The next 2 major trends are big data and analytics. So you can imagine Google, the top of the traffic that likes of Google, Facebook, Yahoo, YouTube are ingesting around the clock. How much data, the avalanche of data just keeps coming. And how to receive and process all those data, okay? So it is something that we cannot do it using the traditional processor, traditional and legacy file systems. So you need to have a better way of ingesting this avalanche of data. And what is a good use? What is the whole purpose for some of these companies to pile up all this data? What is a value into creating, having storing this much data? So the next challenge is extracting value from all this data. Be able to provide value out of this data, and that's the concept of analytics. So the old mindset of having a big data center, big storage solution to house tera, peta bytes of data is over. It's how can you decipher, analyze this amount of data in the most efficient manner, the fastest time, and be able to protect it. So these are some of the major trends that I'm sure you've all heard about, probably in your lines of studies working with, but this is what in the industry we are working on. Ever since I left school 20, 25 years ago, new types of data have been introduced. During my time, and I'm sure you all can relate to it, the only types of data depends on what discipline you are, software or hardware. The only two data in my time, it was analog data or digital data. Now, ever since I left school, now you have different types of data, and the examples are structured and unstructured type of data. In the nutshell, I want to explain these two because that would set the ground for the future slides. Structured data is that anything that has structure. Look at the example would be database applications like Oracle, like Informix. Every piece of the data has exact location, has exact form that needs to go to a specific windows, fields, rows or columns. This is very structured, and when we are reading those data back, we have to go to those areas in order to retrieve what we want. So structured data, again, being spit out by applications like database applications. Whereas the unstructured data, which we see more and more of it, and we are all at the personal level and at the corporate level, we are generating so much of it around the clock. And these are the type of the data that are generated by any of these type of applications. Every time you have created a PDF file, every time you are sending an email, word process, a document, Word, or any of these social media. The data and these don't have any structure. They don't have the exact place that they need to go. Look at this PowerPoint slide. That title could be on the bottom. That page number could be over there. I could have an image here. I only could have text. So there is no any formal or structure to these type of a data. And the bulk and the majority of the data that we see today being generated are considered as unstructured data. So lots of numbers and figures and stats are going to be thrown at you. And as soon as I'm done with these slides and presentation, probably these numbers are no longer be true because more data is keep coming. More data is keep coming. So just gives you an idea that where we're at with the amount of data. So again, today we are, by the way, IDC is one of these research think tanks in the storage industry, data industry. And basically it's back in January when they give that report that 2.8 zettabyte of data is available today. Okay. That was what a couple of months ago, probably it's changed. But again, what is a few peta and zettabytes between France? But by 2020, in 5 years, the amount of the data is going to be what? 40 zettabytes. And if you are doing the math, zettabyte is what? 10 to the power of 21. So today, I'm sure you have a good feel for meg, good feel for gigabytes, probably good feel for terabytes. And what goes after the terabytes? Petabytes, 10 to the power of 15. And what goes after the petabytes? Exabyte, 10 to the power of 18. It's very difficult now to imagine what would be a petabytes or exabytes, but certainly very difficult. I mean, you can tell that all the amount of the data in 5 years would be to this order. And this is the reason, these are some of the reasons. Data never sleeps. This is another eye chart that you are going to be seeing here in this presentation. And this is from a couple of years back, I would admit to it, a couple of years back. And just to show you that why we are getting close to that zettabytes of storage data being generated just at the personal level, at the corporate level, that how much data is getting generated every minute of the hour. Every minute of the hour, globally, how much data is getting generated. The only one of them that we all can we all can relate to it is that over 2 million emails, 2 million plus emails getting generated every minute of the hour. Look at how much application downloads are taking place from the Apple sites every minute of the hour, 47,000. How much queries on search engines like Google are taking place. All right. So these are some of the data being data getting generated at the personal level, at the corporate level, and what does it mean? This is one of the slides that we show at our onboarding programs at my work at NetApp. I work for a company that we are a maker of storage arrays, a storage solution, and one of the first things that we tell our new hire engineers that, hey, more data is good for us. Why? It requires more storage. Given that majority of this data getting generated are bogus, trivial, and we all can relate to it from all those junk emails that we get on our email, right? But still, at the end of the day, if you trash all of those emails, they have to be lingering around for a few more days or hours before they finally delete it out. So more data, good or bad, requires storage. And more storage basically will invites more opportunities, better solutions, better investments on all the areas. And because of this much data getting created, getting generated around the clock, our data centers have been seeing a major, very rapid and major growth. Data center is, again, I'm sure you all heard about the data centers. And perhaps some of you walk by it, you've been to it, small or big. But data centers probably 10, 15 years ago was probably as small as these rooms, corner office, dark office, or somebody's cubicle with a bunch of servers, a dot matrix printer, and a big hard drive holding 100 megabytes of data. That was the data center for some companies, some businesses. Today is the data centers at the enterprise level, at the university-like institutions like here. Yeah, it is a Costco-size buildings with rows and rows and rows of racks populated, filled with servers, networking gadgets, and storage systems. And with lots of wires like a spaghetti factory. So this is the typical data centers. Why? Because the importance of the data. And you can see that why we have arrived at that level of the data centers because of amount of the data, amount of the devices, hardware devices, and also the number of the users that have been doubled, tripled, or going to be 6 times of what is going to be what it was 5 years ago. And it's all due to what? more data getting generated through all these various sites, applications, social media, mobile data, servers, so on and so forth. So this is a typical environment for a enterprise data centers. And managing information assets is a key to any IT managers, data center managers, and the people that are overseeing these data centers. Now, for many companies, it would be very difficult and very, very expensive to maintain and host and manage or administer all these gadgets, all these entities within their own premises. So for the past 10, 15 years, we have been sending many of our data, just like it was not feasible to host all of our pictures, songs, videos on our own laptop, on our desktop, and we had to put them on CDs. Now what we do, we just go ahead and put it on boxes out there on the cloud. That's true for the corporate levels, at the enterprise level. So we send everything into the cloud. And what it drives this movement, adaptation to a cloud, are having as a business justifications, also as far as the IT benefits. I'm sure that you all can relate to these bulleted items. Main thing is scalable. I mean, it would be very difficult today for organizations to keep adding stuff, because if you see a growth, hey, you need to add more processing power, get more servers, more storage, more infrastructure, infrastructure devices, having a higher bandwidth, bigger pipes, better performance. So if you want to do it on your own, yeah, it's going to be very expensive and time-consuming. If you are renting or buying these services from the cloud, probably would be more cost-effective. And this adaptation and these reasons, again, like I said earlier, moving to the cloud or hosting everything locally is an example between owning versus renting. Nobody can convince another person that, hey, for all use cases, going on the renting would make sense. And nobody can convince others owning is better in all cases versus renting. So people adopting or non-adopting this cloud usage is they have to do their homeworks. They have to look at all the facts, and no two situations are the same. But the people that are choosing to go on the cloud are based on these reasons. You pay as you grow. You don't want to pay everything. Look at the previous slide on data center. Majority of the cost and the budgets in the data center is not buying those servers or the storage or those network equipments. The majority of the budget and the cost associated with running a data center is maintenance and the power and cooling and the energy that goes into those data centers. It costs much more than those physical entities, capital equipments. And administrator and there are resources that have to maintain those. So for those reasons, companies try to go to a select cloud because of these reasons. But every one of these reasons have to be looked at carefully and see if it would make business sense to adopt. Now, I've been going on for a while, so any questions? Any questions that you guys may have so far? Okay? Go ahead, please.
So if it's renting versus buying, then who's providing all the cloud services?
The people, the cloud providers. Cloud providers, as we are going to be talking about cloud providers today, just give you an example before I get to the slides. Likes of Amazon, likes of Microsoft, likes of Google. Those are the people that are providing certain services on the cloud, which we are going to be talking about. Yes.
What is the cloud exactly, like in physical terms?
Cloud is a cloud. It is a term. Yeah, it would be very difficult and very simple to explain. But it is something that you do not own. The data is not residing in the case of the personal, at the personal level, the data is not on your own premises. That pictures, that folder full of your pictures is on some sort of a box outside or is on somebody's website. It is not physically located on your laptop or on your desktop computer or the hard drive. It is being hosted somewhere else. And how do you get to it? Through your network connectivity to the internet.
Okay.
But physically, on that Dropbox data center, your pictures are being physically resided on one of those hard drives under storage rack. But it's not locally hosted or not within the premises of an office, corporation, or at the person. Yes?
When setting up a cloud system, who exactly does the basic setup? Is it the cloud provider or is it a business that is buying or renting?
Very good. So, answering your question is, who is providing what?
Yes.
At the user level, which you are, or the companies, and what do they provide as a service provider or service provider? So, if you bear with me, a couple of slides, we'll go ahead and give you the where the lines are drawn. Yes.
How about the security of the data?
Yeah.
And how?
Yeah. So that's one of those things that we are going to get to it as far as the major issue with the security. As soon as that data, you put it on the internet, on the network. Yeah, a lot of the concerns about security, and we'll go ahead and address some of those issues. But certainly one of the major challenges, as we are going to discuss in a few slides, security is one of those things that the conversation will come up.
How about ownership and intellectual property? Is there issues with it? I put data on the cloud.
Yes.
This data technically still belongs to me or to the other company might be able to share some of that.
So the question is, you put the data on the cloud, a picture, for example, you put it on the cloud, you put it on your Facebook. I don't know, I just clicked on that box and I said agreed when I opened up the Facebook account or a Google email, and I didn't read all those fine prints. So I really cannot tell, but those fine prints stipulated that picture that you post from your Christmas party or that email that you put on the Gmail, who owns it? In some cases, people were complaining, I think it was in Europe a while back, that somebody used my picture on my Facebook and without my authorization. And I think that one of these social companies said, hey, when you opened up that account, said that we have control over what you put over here. So yeah, we could use that image for any purposes. You agreed on that. So all of those are the terms and conditions when you sign up for a cloud service or cloud account, exactly. If you have time, I mean, at the enterprise level, you're absolutely correct. That's why there are companies that do the auditing and make sure. That's what I said, that you have to do your due diligence homeworks as far as what you put out there, who's owning it. Exactly, and that could lead to a lot of litigation and all that. Right? Great questions. And another thing is data access anytime, anywhere. So you don't have to carry your laptop all the time to show your pictures when you go home for the weekend or you go to vacation during vacation time. You can access all of your emails, your data from anywhere, from any mobile devices. You can generate data, put the data on the cloud, or receive the data that belongs to you from anywhere. And there would be no interruption. It's always on. And if there's a failure, it's not your fault. You're going to fault the provider. Based on the agreement that you provide, write with the cloud provider, you can stipulate one day for the repair, or 4 hours repair, or instantaneous. And based on that, you would pay a different price. Data centers, when small or big, when it was started before the cloud era, data centers, like I said, small or big, everything was in a silo. For example, the electrical engineering department had its own series of physical hardware, email applications, storage, so on and so forth. Computer science department had its own sets of servers, storage, business applications, so on and so forth. And so many other departments within the universities. A lot of the silos. And also you need to have an administrator, 3 or more administrators momming all of these silos. Not a very cost effective. So what they did over the years, the movement was going to consolidations, multi-tenancy. So you can see that now, what you see, the dotted lines over here, everything is virtualized. Everything is virtualized and consolidated. We'll talk about the virtualization later on, but the virtualization to begin with, I don't know, I'm sure you heard about the virtualization, but the virtualization is a big lie. It's creating illusion of something that we do not physically have or possess. And every one of us are using, in our daily life, have been using virtualization for years. When we go to the Best Buy and purchase this $3,000 flat TV, when we only have what? Only a couple of thousands on the bank account. How do we use it? Plastic, a virtual money. We deal with paying the whole thing later on, but not at that instance. So virtualization allows us, in the case of the data, in the case of the storage and data center and cloud, virtualization allows us to scale and making the performance better. So the movement is going from physical devices to virtual and all the way to multi-tenancy, that, hey, you are the users here, but you don't own on the premises on the ground of your business, university, any physical entities. You are just using all the services from the providers. Still, after like 10, 15 years of introduction of the cloud, there are many, many definitions about the cloud. And there's nothing hard and written in stone. The boundaries are changes, definitions are varying, depends on the vendors or who are the providers. But these are some of the fundamental features, definitions that can better define the cloud. Ability to scale and provision dynamically in the cost-efficient way. Ability to make the most of the power without having to manage the complexity. So it removes the hardware and software complexity from the user, and it will only allow the user to concentrate, let's say, on development part of the job. So these are some of the features of the cloud. And over the years, different type of the clouds have been introduced. Different flavors of cloud have been introduced. From the private cloud to the public and something in between called the hybrid. All of these are cloud flavors. All of these cloud flavors, they all have similar characteristics. Some similar features. You can reach, with the cloud solution, you can scale. If you need more processing power, if you need more storage, if you need more bandwidth and throughput, that's that scale. Again, we talked about the virtualization, that how you can accomplish something without physically have those resources. That's a virtualization. You have it in the server virtualization, you have it in the form of, which I'm sure you're all familiar with, how we can replace 3 or 4 servers running 4 instances of operating system. One server running Microsoft, the other one's running Windows, Linux, and Unix. How can we replace these 4 physical servers with only 1 server and having like 4 virtual machines? That's virtualization. Low-cost software. You don't need to own your business applications. You don't. Those business applications are expensive. Well, you can go ahead and get it from the cloud. Just like the Gmail that you are using. You have a choice of going to Fry's or Best Buy and buy Outlook CDs from Microsoft, and use it and load it on your laptop or on your desktop, or just get the free version of email application over the net from Google. Definitely costs less. But the issue will come up that who owns your content? Who can read and not read your messages? And that has to do with the security issues that these providers have to divulge with you and disclose with you when you are signing up for these services. And it's pretty much on demand, and all of them providing these they advertise broad network access, resource consolidations, and based on the services that you can measure, they charge you. Just like the way that you have your internet, your cable at home, services at home, you pay for what the amount of the performance storage capacity that you're using. So a few more slides before we have this before the break, for lunch break. But this is the idea that over the years, companies, this trend has started to move bulk of their data processing because it become very expensive to manage, process their data in-house. So it is cheaper, more cost-effective, with a better, more performance after they've done their homework. Like we said that, hey, it would be a very career-limiting move for an IT manager or for the technical officer overnight say, hey, tomorrow I want to move to the cloud. No, you need to, it needs to be studied and all the aspects have to be addressed. And that's why they moved to a cloud model for all of their data processing, which would promise them gain in business productivity and advantages that cloud services would provide. And this is basically what you're looking at, the traditional silos, everything physical on premises, that now that through the virtualization, all of these entities are moving into the cloud. So here, for this one of the applications, one of the examples, for years at UC Santa Cruz, we've been using Microsoft Outlook. Year after year after year, we had to go and buy licenses, buy CDs from Microsoft, so we would have the internal email system, and somebody had to manage it. For the last couple of years, we said goodbye to Microsoft, and what? Guess what? Gmail. So we went to Mr. Google and said, hey, can you provide us with a Gmail that every one of the students can access over the cloud, and everybody has a Gmail account. Of course, that would be a different type of a Gmail service that you and I have at a personal level, but still, we don't have to purchase any CDs. They just give us a link, and we can get to our email account. So this is, as you know, this is private. You know it as being inside of the firewall or the VPN. Still is within the premises. Nobody else can come in. That's the example of the private cloud. But here, the EE department, computer science department, computer engineering department, they're all using the same resources. We don't have those silos. Or going into the cloud that you put your data that everybody can, accessing the same services, resources that everybody else is using. And in between, you can go back and forth, call it a hybrid cloud. So let's go ahead and put a break on. When we come back from lunch, we'll go ahead and pick it up from here. And meanwhile, if there are any questions, we'll be definitely look forward to chat with you while you're having your lunch.